In this lesson you will learn about proportions. Proportions are just equivalent ratios, two ratios that are equal to each other. So in this example I have 1/2 equals 3/6 equals 8/16. All of these fractions are equal to 1/2. So the missing number on this last fraction must be 12. 12 over 24 is also equal to 1/2. So when you have two fractions that are equal to each other, it's called a proportion. And if I rewrite number 1, 3/7 equals x over 28, the way to solve a proportion is to use what's called cross multiply. So I take this product, 7 times x is 7x, and I take this product, 3 times 28 is 84, and I just place an equal sign in between. So 7x equals 84. It doesn't matter which diagonal you start with. I usually start with the one that has the variable and I place it on the left side of the equation. But to finish this, you want to divide both sides by 7 so that x is equal to 12. For number 2, 4 over 15 equals 6 over x. So I'm going to start with this diagonal on this example because this diagonal has the x, and I multiply 4 times x is 4x, and then I take this diagonal, 6 times 15 is 90. I place an equal sign in between, and now my fraction is gone. So to finish this, 4x equals 90, I want to divide both sides by 4 so that I get x equals 90 over 4, and I can reduce 90 over 4 by 2 so that my final answer is 45 over 2. For number 3, x minus 20 over 5 equals 6. So this example might look different for two reasons. One is that we just don't have an x. Now we have an x minus 20. The other is that 6 is not a fraction. So an easy fix to that is just take 6 and write it over 1. As long as you have a fraction on one side, you can easily turn the other side into a fraction by writing it over 1. So I'm going to start with cross multiplying, and I will take this diagonal first because this one has the x, and it's 1 times x minus 20. So I will write that like this, 1 parentheses x minus 20. And then I take this product, 6 times 5 is 30. I place an equal sign in between, and the 1 gets distributed to both numbers in the parentheses, and it doesn't really change anything, it's just x minus 20 still. And to finish this one, this time I'll add the 20. You always want to get x by itself at the end, and by cross multiplying you're turning it into a simpler equation. So my final answer is x equals 50. For this example, I'm going to show you this one a little differently. 18 over 57 equals x over 19. So this example could be done by cross multiplying. You would get the same answer as if I did So if you look at the numbers in this problem, we have 18 over 57 and x over 19. By cross multiplying, it looks like the product of 18 times 19 would be very large, and then to have to divide that by 57. So here's a trick that you can do. It doesn't always work, but if you see it in a problem, feel free to use it. If I take 57 and divide it by 3, I get the number 19. So I'm going to use the same number of 3 and divide 18 by 3, and that's going to give me the number 6, so my answer is x equals 6. So I'll rewrite the problem and show you again by cross multiplying in case that was confusing. So I start with this product because this one has the x. 57 times x is 57x. And then if I take 18 times 19, I'll show that work on the side. I get 342. Place an equal sign in between. And to solve for x, I have 57 times x, so I divide both sides by 57. The 57's cancel. And now to figure out 342 by 57, I would have to use long division. And if I multiply 57 times 6, 57 goes into 342 evenly, so my answer would be x equals 6. So both of these methods work. So if you notice that the denominator or the numerator can divide by a number to get to the other denominator or numerator, you can use it on the opposite, but you have to use the same number 3. For number 4, we have 18 over 57 equals x over 19. So I start with this product, because this one has the x, and I have 57x. So for number 4, I have 18 over 57 equals x over 19, and I have two fractions that are equal to each other, so I take the product that has the x, and 57 times x is 57x, and then I take the other product, 18 times 19, and if I multiply 18 times 19, I get 342, and then I place an equal sign in between, so my simpler equation is 57x equals 342. The only problem with this example is that we have much larger numbers than what we've seen earlier. So I divide by 57, and when I divide by 57, I would have to use long division, so I divide 57 into 342. And if I estimate and change 57 to 50, just to get a ballpark, 6 times 50 is 300. So that's close to 342, but we know that 6 times 57 will be a little bit higher. So if I start with 6, I get 342, so it goes in evenly. So my answer is x equals 6. I do want to show you on this problem another way that this could be solved. So I'm just going to rewrite the problem as 18 over 57 equals x over 19. If I take this denominator and this denominator, 57, and if I divide 57 by 3, I get the other denominator. So if you notice this happening in a problem where you can divide either the denominator or numerator to get the one on the other side, you can use this same number on the other part of the fraction. So if I take 18 and divide it by 3, that gives me 6, which represents this x. So only on problems where the numbers look like cross-multiplying is going to give you a large product, like it did here, it gave us 342, and then to have to divide 342 by 57, look for tricks like this. For number 5, 6 over 3 minus x equals 2 over 7. So I start with this product, because this one has the x, and I take 2 parentheses 3 minus x, and then I take this product of 6 and 7, and I place an equal sign in between the two products, and I solve the equation. So even though I have distributing, it's still easier to distribute than have to work with a fraction. And I have 6 minus 2x equals 42. And this is a positive 6, so I want to subtract 6 from both sides. Always look at the sign to the left of the number. This negative belongs to the 2, so that these cancel, and I'm left with negative 2x equals 42 minus 6 is 36. And then I divide both sides by negative 2, so that my final answer is x equals negative 18. Now for the last 5 problems, we'll look at some word problems. And setting up word problems by using proportion So for the next 5 examples, we will look at word problems that involve proportions. So in number 6, we have 6 bracelets cost $15.50. So before I read on, I'm just going to label this as 6 bracelets cost $15.50. And the second part of the question is saying, what is the cost of 9 bracelets? So I'm going to put 9 on this side so that I have the bracelets on the left. And since I'm finding the cost, I'm going to place an x here, so that this turns into a proportion. And I have 6 over 9 equals 1550 over x. It's okay that you have decimals. You just want to make sure that you have everything that has to do with bracelets on one side and everything that has to do with money on the other side. And once you have it set up, you cross multiply. So I have 6x, and then 9 times 1550, and 9 times 1550 is 139.50. Place an equal sign in between, and then divide both sides by 6. I'll show you the division on the side. So 6 goes into 13 twice, and then into 19 3 times. Into 15 twice, and then into 30 evenly 5 times, so that x is equal to 23.25. And since this represents money, I want to make sure I include a dollar sign. So the cost for 9 bracelets is $23.25. For number 7, Faith is making chocolate chip cookies. The recipe requires 2/3 cup of brown sugar to make 12 cookies. So if I just stop here for a minute and label 2/3 cup of brown sugar will make 12 cookies. How much brown sugar will she need if she wants to make 20 cookies? So I want to put the 20 on this side. I'm finding how much brown sugar, so I put an X here, and I turn this into a proportion. So I have 2/3 over X. So 2/3, and I just want to make this line really big to show that 2/3 is the entire numerator, equals 12 over 20. And I cross multiply. 12 times x is 12x. And then 2/3 times 20. So I take 2/3 times 20. When you multiply fractions, you multiply straight across. So I have 40/3. So 12x and 40/3 are my two products. I put my equal sign in the middle. And what I'm going to do on this problem is I'm going to cross multiply again, because I have a fraction equal to a number, which I can easily turn into a fraction. So I have 36x, and then this product is 40. And I divide both sides by 36. This will be my final step in solving the equation. And I get x is equal to 40 over 36, which I can divide both sides or both parts of this fraction by 4, so that I get x is equal to 10 over 9, which is the same as 1 1/9. So since this is a word problem, I want to say that it's 1 1/9 cup of brown sugar. For number 8, this is an example of a scale drawing. A map has a scale of 1 to 40. And 1 to 40 means 1 inch equals 40 feet. So when you measure out 1 inch on a map, the actual distance is 40 feet. So if the distance between 2 points on a map is 3.5 inches, so 3.5 will go underneath the 1 inch because we want all the units that are the same lined up. What is the actual distance? Well, the actual distance is in feet. So here's my fraction. So I have 1 over 3.5 equals 40 over x. Now you can write 3.5 as either 3.5, or 7 over 2. I'm going to write it as 7 over 2. And I start by cross-multiplying the diagonal that has the variable. 1x is just x. And then I take 7 over 2 times 40, which on the side, 7 over 2 times 40 is 40 over 1. I can reduce the 2 with the 40 and make it a 20, so I have 7 times 20 is 140. So on this problem, my problem is actually finished. I get x equals 140, but I just want to label that as 140 feet. For number 9, Jennifer can run 1 lap around the track in 4 minutes and 20 seconds. So this 1 lap, be careful that you don't miss that there's another number in there. We have 1 lap, can be run in 4 minutes and 20 seconds. So we have 2 different units here. How many laps can she run in 10 minutes? Well, I'm going to place the 10 minutes on this side, even though we also have seconds. We're finding how many laps, so my x is placed here. And here's my fraction. So I have 1 over x equals, now this 4 minutes and 20 seconds, we have 4 minutes plus 20 out of a possible 60 seconds, because we have 60 seconds in a minute, is the same as 4 plus 1/3. The zeros cancel, and 2/6 reduces to 1/3. 4 plus 1/3 is just 4 1/3. And if we write that as an improper fraction, we get 13/3. So instead of putting 4 minutes and 20 seconds into my fraction, I'm going to put 13/3. And then over 10. So that I'm cross-multiplying 13/3 times x So I start by cross-multiplying x times 13/3. So 13/3 times x is x over 1, gives me 13x over 3. And then 10 times 1 is just the number 10. I place my equal sign in between, and I have another fraction, so I put the 10 over 1, and I cross-multiply again. 13x times 1 is 13x. 3 times 10 is 30. I place my equal sign in between. To solve for x, I divide both sides by 13. And I get x is equal to 30 over 13. And I'm going to show you the work on this one. 13 divides into 30 2 times, with 4 left over. So I could also write this as 2 4/13, which makes sense since it's a word problem. We're finding how many laps, so it's 2 4/13 of a lap. And the last problem, number 10, Maria earns $68 for 8 hours of work. So we have $68 for 8 hours of work. How much does she earn for 30 hours of work at the same rate? So 30 hours goes on the right side, so you line it up with hours. We're finding how much she earns, which is money. So here's our fraction. And we have 68 over x equals 8 out of 30. And I start with this diagonal, 8x, and then 68 times 30. So if I take 68 times 30, I get 2040. And then I divide both sides by 8. So I take 8 divided into 2040. 8 goes into 20 twice, and into 44 5 times, and into 40 evenly 5 times. So my x is equal to 255. And x represented how much she earns, so I will say that she earns $255.